Welcome back to Firewall Life YouTube channel. Today I'm going to continue Palo Alto deployment in Azure Part 3. Here today I have noted down the points to be covered. I think that is really helpful for me to complete all the theories. So here we have the first point is steer inter-subnet traffic, that is east-west traffic, because in previous demonstration I demonstrated you how to steer north-south traffic. So that is the traffic from internet to our servers and traffic initiated from our servers to internet. So the second point is enable threat prevention. So in order to secure traffic, north-south traffic and the east-west traffic, we need to enable threat prevention in Palo Alto next generation firewall. When it comes to Palo Alto next generation firewall, threat prevention covers malware protection, vulnerability protection, and we have file blocking options, and we have DLP options, data loss prevention options, and we have so many features. So our third point is secure server remote administration using Globalprotect, because in previous demonstration I advised you to not to expose server public IP addresses to internet because there can be so many brute force attempts to your servers. So using Globalprotect SSL VPN option in Palo Alto next generation firewall, you can administer your servers securely through a VPN connection. So let me go to Azure Portal. Here in Azure Portal we have our FLife DB, so that is our database server, and here we have the WWVM, so that is our web server, and here we have our firewall. So I think it's better if I can draw the diagram first and give you the idea. So let me draw it. Let me select the color. Shall we get this blue color? Okay. Here our setup is, because I have already explained the setup, but it's better if I can explain it again. Here we have our Palo Alto firewall deployed in Azure Virtual Network. This is the Palo Alto firewall PA, and this is the Untrust interface. Untrust. Here we have our trust interface, and this Untrust interface is connected to Untrust subnet. Here our trust interface is connected to our trust subnet, and here we have management interface. This is our management interface. It is connected to our management subnet in Azure Virtual Network. Okay. So then here let me change the color. So let me get green. Here we have our database. Here we have our web subnet. This is the web subnet. This is our web subnet, and here we have let me change to some other color. Let's say purple. This is our database subnet. This is our database subnet. So let me explain you the traffic scenario at the moment. I mean the current traffic scenario. So okay, the current traffic scenario is when we ping from web subnet, because in web subnet we have a web server deployed, in database subnet we have a database server deployed. So if you have initiate a ping from web subnet to database subnet, traffic travels directly to database subnet. And if we initiate a ping from database subnet to web subnet, the same scenario happens. So direct communication is there. Because I think you can remember I mentioned in my previous both the previous demonstration, when it comes to Azure Virtual Network, virtual subnet communication enabled by default, because we do not have to put anything. All the routing and everything is enabled. So here these communications are happening directly without any firewall or any threat prevention solution. So now our plan is to steer this traffic through our Palo Alto next generation firewall. So before giving you the idea about the new traffic scenario, let me go to my web server and let me initiate a ping request to my database server. But I think I had to get the IP address from the database server. I cannot remember the IP. IP address is 240.36. So let me ping 192.168.240.36. You can see now we can ping to our database server. So let me stop the ping. Let me interrupt the ping. Now we are in web server. So let me go back to database server and ping web server. So anyway, we know obviously we have two-way communication. So let me get the IP address. My web server IP is 240.4. So let me go back to database server and ping 192.168.240.4. So obviously we have communication to from database server to the web server. So now so let me go back to the diagram. Okay, so let me change the color. Okay, so now what we are going to do is we are going to steer traffic to the firewall. So our new traffic scenario should be when we try to contact database, or when we try to communicate to database from the web server. So the communication should be directed to firewall trust interface. When we try to contact database from the web server, the traffic should be directed to Palo Alto next generation firewall trust interface. So what happens is, when the traffic received to the Palo Alto trust interface, we can configure, I'll let you know how to configure. We can configure Palo Alto next generation firewall to forward the traffic to database server. Okay, so when the database server replies, so that reply packet, so let me change the color. When the database server replies, so the reply also will be sent to Palo Alto next generation firewall trust interface. So then the Palo Alto firewall, we can configure Palo Alto firewall. I'll let you know how to configure. We can configure Palo Alto firewall to forward the traffic back to web server. So Here in Palo Alto Firewall, we can secure this traffic using many actions. So let me change the color. So here in Palo Alto Firewall, we can enable. The first thing is we can enable. So let me write it here. The first thing, we can put security rules. We can put security rules. The second thing is we can enable threat prevention. We can enable threat prevention. So using these methods, we can secure this traffic. So if you get the first point, security rules means we can open whatever the required traffic. I mean, we do not want to open all the ports and all, so we can enable only the required ports. But even in Palo Alto Firewall, we can not only secure using ports, but we can secure using applications. Let's say we have a MySQL database. We can enable only MySQL application. So when the web server communicate to database, we can put a security rule using layer 7 rules in Palo Alto next generation firewall, asking the firewall to only allow not the database port number. As I remember, 3306 is the MySQL database port. So we are not going to open that port, but we are going to open MySQL application. So if a malware is going to communicate through the 3306, it cannot be happen, because Palo Alto Firewall understand this is not MySQL database communication. This is something else, even though it is communicating through the standard MySQL port. So that is the one aspect of security configurations in Palo Alto Firewall. And the second thing is enabling threat prevention. So enabling threat prevention means we can enable malware prevention, we can enable vulnerability protection, we can use file blocking options to block several file types, and we can enable data loss prevention, and so many security precautionary actions can be taken using Palo Alto next generation firewall. So in that scenario, let's say I'm giving you one scenario here. Let's say here, let me get another color. Let's say if malware is, if some user from the internet accessing our web server, and if he is going to put a malware here, but when it comes to our previous demonstration, we enable north-south traffic. That is mean users from the internet accessing our web server through the Palo Alto firewall. In that scenario, we can prevent malware. But I am just giving you a scenario, just neglecting that previous configuration. Let's say one person is going to communicate to the web server and put a malware here. This is a malware, but the thing is, this malware cannot propagate into database server, because when the malware is trying to communicate to the database server through the firewall, this firewall is going to block that communication, because firewall has the intelligence to identify this malware using several methods. Okay. So let's understand the detailed traffic scenario using IP addresses and all. So let me draw the diagram. Here we have our Palo Alto firewall. So let me change the color. Okay, here we have our Palo Alto firewall. Palo Alto firewall, and for the moment, for this scenario, actually we need only the trust interface. This is trust, is the first interface. And here we have our database not database but the web subnet. This is the web subnet. www. And this is the database subnet. So let me get the subnet addresses, because we are going to have a detailed diagram in order to understand the traffic scenario. Let me go to virtual networks, F-Live virtual VNet, and go to subnets. And this is our web subnet, and the subnet address is 192.168.240.0/27. 240.27. Uh, 192.168.240.0/27. Okay, so let me check the database subnet. The database subnet is 240.32. 240.32. 192.168.240.32 slash, sorry, I'm sorry, /27. Okay, so let me get the trust subnet IP address range. That is a firewall subnet 240.96. 240.96. 192.168.240.96/27. Okay. So here in web subnet we have to have a route table. In the route table we have to put a routing entry that is called user defined route, UDR. In web subnet route table, what we are going to do is, so let me get the Palo Alto firewall trust interface IP address first. Let me go to virtual machines. So let me go to networking and let me get the trust interface. IP address is 192.168.240.100. So let me write the IP. So my IP, the Palo Alto trust IP is 192.168.240.100. Okay, this is the trust interface IP address. So so in web subnet we have to put a UDR. The UDR, in UDR we have to ask if our web server wants to communicate to 192.168.240.32, that is the database subnet. So if the web server wants to communicate to 192.168.240.32, 32. This is the database subnet /27. Then the next stop is 192.168.240.100. So that is the Palo Alto Firewall trust interface. This is DB subnet, and this is the next stop for the DB subnet is PA trust interface. Okay, so we have to put this using a route table, and in the route table we have to put a user defined route. Okay, so then get the database subnet. In database subnet, we have to ask database subnet if you want to communicate to the web subnet, that is 192.168.240.0/27. then you have to communicate to, or you have to forward traffic to firewall trust interface 192.168.240.100. So this subnet is web subnet, and this next stop is PA trust interface. Okay, so this is the entry should be put in the database subnet route table. In the route table we have to put a user defined route. So in the firewall side, in the firewall we have to have two routing entries in the firewall PAN OS. In the Palo Alto PAN OS, we have to put two route entries. So that is, in the Palo Alto virtual router, we have to tell Palo Alto if you want to send traffic to the web subnet. So that is 192.168.240.0/27. So then please send that traffic to this trust subnet. This trust subnet second IP. So that is the default gateway of this trust subnet. I think you can remember I explained that in both the previous demonstration. So in this second IP, because the subnet IP is 192.168.240.96, so second IP should be 192.168.240.97. So then we ask Palo Alto Firewall if you want to reach 192.168.240.0 subnet, that is web subnet, so please then send that traffic to 192.168.240.97. and in that routing entry in the Palo Alto default virtual router routing entry, we are asking Palo Alto Firewall to forward web subnet traffic to this default router IP of the trust subnet of its trust interface. So we have another subnet, that is database subnet. So then we have to ask Palo Alto Firewall if you want to forward traffic to database subnet. So that is 192.168.240.32/27. then forward that traffic to the same the trust subnet virtual default route IP. So that is 192.168.240.97. Okay, so we have two routing entries in the Palo Alto. This is one, this second. This is the first and second. Okay, so then let me go to OneNote, because I have noted down several points. When it comes to Azure routing, we have three important points to be noted when it comes to Palo Alto deployment. The first thing is route traffic between subnets using same interface. So let me explain that. So let me change the color. Let's say in on-prem solution, just give me let me give you comparison. In on-prem solutions, normally what we have is we normally deploy a firewall. This, let's say, is a firewall, and we have several interfaces. Let's say this is DMC. Let's say this is. Let me get the same scenario. Let's say this is our www subnet. Sorry. Let me delete that. Okay, so let's say this is our www subnet, and let's say this is our database subnet, and all those subnets are connected to separate physical interfaces of that firewall. Okay, so this is our let's say some other subnet. Okay, so in this scenario, let's say www server wants to communicate to database server, so the traffic would be sent to its firewall interface. So that is its default gateway, this file interface. So then routing happens in the firewall, and then that traffic would be sent to the database server. So that is a normal scenario. And also we have another scenario when in a on-prem scenario, normally we can use VLAN. In VLAN scenario, let's say we have one interface, physical interface, and we have virtual sub interfaces, or the VLAN tag sub interfaces. Let's say this one is sub interface, this another sub interface, and this another sub interface. So let's say here we are connected to a switch. This is a network switch, and we have VLANs. Let's say this is our www VLAN, and here we have our database VLAN. So since this is a trunk, because this firewall interface we call as a trunk, because these are sub interfaces. So when we want to communicate to database server, so from the web server, we can send then traffic to whatever the sub interface that belongs to our www VLAN. So let's say this is the that sub interface. So we send that traffic to the this sub interface. So the traffic routed through the sub interface to the, let's say this is the database sub interface. So this traffic route through the interface and exit from the database sub interface and reach the database. So this is VLAN scenario, because this file has a single physical interface. We divide it into sub interfaces using VLAN tags, and we connect that firewall interface into a switch, and we have separate VLANs in the switch, and we have one VLAN called www, one VLAN called db. So that is that. So we have two scenarios. We can have physical interfaces and we can have sub interfaces. But in Azure, this is totally different, because in Azure, normally what we do is we normally have only three interfaces in Palo Alto deployments. We are going to have one interface that is totally dedicated for management, and we are going to have one interface that is Untrust interface, that is going to be used as the internet interface. This is Untrust. Okay, so then we have another interface that is going to be named as Trust, or whatever your required name, Trust. And all the subnets, let's say we have here in this our scenario, we have two subnets. We have, this is our www subnet, and we have database subnet, db subnet. Let's say we have another let's say development subnet. Let's say we have another subnet called let's say file server subnet, fs subnet. We have so many subnets, and all these subnets are going to use the same physical interface, that is the trust interface. So my first point is route traffic between subnets using same interface. So here, so in on-prem scenario, what we do is when it comes to physical interfaces, we have one physical interface per subnet. So that means in this physical interface we have a switch and we connect all the devices, and we have another physical interface, we connect a switch and we connect all the devices. But in this second scenario, we have one interface, that is a trunk, and it has VLAN sub interfaces. So we connect it to a switch using a trunk port, and we have VLANs in a switch, and we communicated through the trunk between these VLANs. But here in this Palo Alto deployment in Azure, we have only one interface, and we can communicate all of our subnets, or the subnets in virtual network can communicate this trust interface. Okay, we all can communicate to this trust interface. But the difference is that is the third point. Okay, so third point. But before coming to third point, let me explain this. So here, let's say if you want to communicate to database subnet, what we are going to do is we are going to initiate connection from the web server and send that traffic to the trust interface, and through the same physical interface, we are going to route that traffic back to database. So let's say if you want to communicate to dev environment using file server, so we are sending traffic to trust interface, and traffic will be routed using same interface, because here we do not have any sub interfaces, we do not have VLAN tags, we do not have any anything. We have only one physical interface. Okay, physical interface means it's a virtual, I know, because it's a virtual environment, but it's a totally one interface. So then traffic would be routed through the same interface and sent back to the dev environment. So that is my first point. First point is route traffic between subnets using same interface. And here we have one important thing, that is using, let me come to second point later. So let me go to third point, using different subnets interface. Using different subnets interfaces as the next stop. Yeah, using different subnet interfaces as the next stop or the default gateway. So that means, let's say here this subnet and this trust subnet, this is another subnet actually. This is also different subnet. This is trust subnet of the firewall. This is trust subnet actually. So then this is another one subnet, this is another subnet, this is something different, some different subnet, and this is another subnet, and this trust subnet also another subnet. So in normal on-prem deployments, this web subnet can have a default gateway, so that should belongs to this web subnet, because if this web subnet is, let's say, 192.168.1.0/24, it cannot have some different gateway. So that means we cannot have 192.168.2.0 range next stop or default gateway. The default gateway must be belongs to the same subnet. Here also same, even though this is a virtual LAN, here let's say the web subnet is 192.168.2.0, the default gateway or the sub interface belongs to this VLAN should have the same IP address range, 192.168, let's say 2.254. That is the on-prem scenario. But in Azure, here let's say our web subnet has 192.168.2.0 subnet range, but we can have next stop of, let's say this trust subnet is 192.168.100.0, so then we can have next stop 192.168.100.0.254 next stop for the default gateway. Let's say if you want to access a database server through the firewall, the connection is going to be initiated from the web subnet. So then, let me change the color. So then we can put a UDR, we can put a user-defined route, In user-defined route, we can tell the www subnet, if you want to communicate to this database subnet, that is a total different subnet, your next stop would be the trust interface IP. So that is a totally different subnet IP. So your next stop would be this. So then you can understand that in on-prem scenario we cannot do that. In on-prem scenario you can't tell if you want to communicate to internet or the database subnet. If your data www subnet IP is, let's say, 192.168.1.0, you cannot tell your next stop would be, let's say, 172.16.1.1. You cannot tell that. This cannot be done. But in Azure you can do that using user defined route. You can do that. So I'll show that to you. So our second point is filter traffic between subnets using same zone. Since we have only one interface here, this interface, when it comes to Palo Alto, this interface can belongs to only one security zone. But in normal scenario, in on-prem scenario, we can have several security zones, because we have in one scenario we have several physical interfaces. In this physical interface we can have one security zone. In this physical interface we can have another security zone. In here virtual network scenario also, this virtual sub interface can have one. This sub interface belongs to one. This sub interface belongs to another security zone, and this sub interface belongs to another security zone. So in both the scenarios we can filter traffic between different zones. So let's say this is www zone, this database zone. So we put traffic filtering rule between two zones. Okay. But here, since we have in Azure environment, since we have only one interface, so we cannot put traffic rules or the filtering rules between zones. We have to put intra-zone rules. So that means that this rule is going to be between same zone. So the traffic rule is between same zone. Let's say this is here let's say we have only one zone. This is trust zone. Okay, in the firewall we have trust zone. So what we do is we put the traffic rule. The source zone is trust, and destination source zone also trust. Only differentiation can be done using the source IP and the destination IP, TIP. So in this rule, we put source IP as the web server and the destination IP as the database server. But the source zone and the destination zone is the same zone. So I think you got the idea. So about these 3 points. So let me go to the Azure Portal and the Palo Alto Firewall in order to do the configuration. Okay. So let me create the UDR first. So here we have already assigned a UDR to our web server subnet. Actually by mistake I used trust route, but if I can use web route, that is more meaningful, but it's okay. So, and here another thing, here you can see that we have a default route, that is 000/0. Sometimes you may think, so I know that this demonstration also be a lengthy one, so but nothing to do, because I have to explain everything, otherwise there is no point of teaching without explaining everything. So let me explain that, because this is also important, extremely important. Here can I explain using same diagram, but it's not that much clear, right? Okay, let me explain using the different diagram. It takes time, but I think this when I was starting the demonstration, I mentioned several points that I'm going to cover, but subnet enabled representation secures, but here also as I can see, I only can complete first point, steer inter subnet traffic east-west. I have to do another demonstration for these two, enable threat prevention and secure server remote administration using Globalprotect, because here it takes some time to explain all the theories behind the Azure routing. So in that scenario, let's complete the first and stop the demonstration, and let's start another demonstration for last 2 points. Okay. So then here this is my point, because you saw that in my this trust route is trust route means my route table assigned to the web subnet. So here this is my PC route, so that means I want to access my PC without using the firewall. So you just check my previous demonstration, I explained that. Here in default I have a default route. Okay, so I have a specific thing to tell you, special thing to tell you. So here I have this so let me change the color. Okay, here I have the firewall. Here I have the firewall, and here this is my trust interface. This is my trust interface, and I have my web server subnet here. This is www, and this is the database subnet here, db subnet. Here I have already assigned a route table. We have a route table here. We have already assigned, and we have a default route here. We have a default route asking 0. If this is the destination, send that traffic to firewall trust interface. That is the UDR, user defined route, in this route table, which is assigned to www, the web server. But here my database subnet IP is, I just want to check that my database subnet IP is 192.168.240.32. Let me write that 192.168.240.32/27. okay. But even though we have this default route, if this web subnet is going to communicate to this database subnet, that is 192.168.240.32, this traffic will not be routed to this trust interface. This traffic will not be routed to this trust interface, even though we have this default route pointing to the Palo Alto firewall trust interface. Because normally in normal networking theories, the longest prefix match. So that means in this scenario, our destination is 192.168.240.32. So what this WW normal network, what this WW subnet checks is, it checks do I have any specific route matching this destination. If it does not have that type of a specific route, so it is going to match the next broader route. So that is default route. If it does not have any route specifying 192.168.240.32 and asking to send to some destination or the next stop, so it's going to use this default route. But here it's not going to happen, because in Azure, I think in previous demonstration I explained to you, in Azure there's something called system routes. System routes. In system routes, all these subnet ranges are mentioned. All these subnet ranges are mentioned in system routes. All the subnet ranges are mentioned. So that means in the system routes, this destination mention and put a route by default. I mean, I'm not the one who put that route, but that is by default. It asks if www subnet wants to communicate to 192.168.240.32, just send that traffic directly. So this route is there. So in that scenario, even though you put this user defined route 000/0 and next stop is trust interface of the firewall, this is not going to be used for this traffic. So in that scenario, you have to put user defined route, specific user defined route, telling that not 00, but telling the destination is 192.168.240.32/27, then send traffic to trust interface of the firewall. So this is really important. Okay, so let me go to the firewall, and is the firewall, and we have so Okay, so let me I'm going to do one change to the default rules in the Palo Alto firewall. When it comes to Palo Alto firewall, we have two default rules. The first rule is interzone default. So interzone default means, so let me explain. Interzone default means, let's say we have two zones. Let's say we have two zones. Two zones means we have one interface here, we have another interface here. That interface belongs to this zone, and this interface belongs to that zone. So here is a host, and here's another host. If this host is communicating to this host, so this traffic can be classified as interzone. Interzone. Because this is between zones, because this is one zone, this is another zone in Palo Alto firewall. So let me go back to the firewall. So this means interzone default means the action, let's check the action is deny. So that means by default deny all the traffic between different zones. So that means unless otherwise we put a specific security rule, this traffic should be blocked using this rule. Okay, that is interzone default. And we have another another rule, intrazone default. So let me check the action. It says allow. So what is intrazone default? So let me explain. Let's say we have a zone here. Let's say we have a zone. Or otherwise, I think no, just no. This is not that much. This is not going to be make sense. So let me delete that. So let me go back to previous explanation. Here, it is fine. Here, intrazone means here this is the trust zone. This is the zone of the firewall. So this database, the web subnet is going to communicate to database subnet through the trust interface of the firewall. So we are going to configure that within another few minutes time. So then this database, web subnet. So let me change the color, otherwise you won't identify my drawing. So this web subnet is going to send traffic to firewall trust interface, which is where the interface belongs to trust zone of the firewall, and then this that interface forward the traffic to the database subnet. The web subnet send traffic to the trust subnet interface that belongs to trust zone of the firewall, and then the firewall would forward the traffic to database subnet. So since this traffic belongs to same subnet, because traffic comes to the trust subnet and then forward to the database subnet within the subnet within the zone, I mean same zone. This is same zone traffic. So this is called intrazone traffic. This is intrazone because it's coming to the trust zone and going out within the same zone. So this is intrazone, not inter. Inter means between two zones, two different zones, but intra means within same zone. Okay, so that is interzone. So let me go back to the firewall. So here this rule says this intrazone traffic allowed by default. So in that case, here this traffic is allowed by default. But the thing is, actually, I want this traffic to be blocked by default, because I don't want all the subnets to communicate without any restrictions. I can put specific rules in order to allow specific required communication. But let me go to firewall. In on-prem solutions or the on-prem deployment of Palo Alto firewall, normally we do not block this rule. I mean, intrazone default is this is the action. is allowed. But here we have to block that. But let me do that later. So here, let me do the route configuration. So this is trust route. This belongs to the web subnet. So let me add a route. This route, let's say this is DB route, because I'm going to put the address prefix that is the destination IP range is 192.168.240.32. I think I can remember our database subnet is 32, I guess. Yeah, 32. Okay, so let me go back /27. So then I'm asking this UDR to put that traffic to virtual appliance. That is my firewall trust interface IP. That is 192.168.240.100. Okay. So now it's going to send that traffic to firewall trust interface. So let me click OK. So it is getting saved. So let's wait for some time. So it says it has been successfully added. But I have to give you some practical tip. Even though this says it has been successfully added, you have to wait some time, at least 20 to 30 seconds, because normally, according to as per my experience, it takes some time. Even though this shows it has been added, most of the time it is still not added. I mean, that is not a fault or anything, but that is that. So you just have to remember, because otherwise what happens is you just add a route and you just after adding the route, you are going to check that if it is not going to be, it's not going to work. So then you just remove the route and you are going to try something else. Don't do that. Just add the route. Even though it says it has been successfully added, you just wait at least 1 minute time or 2 minutes time, and then check if that is not working. So then there can be an issue, because otherwise you are going to get misled. You are going to misled. So don't do that. Okay, we have added a route, DB route. So this asks if this web server subnet wants to communicate to DB subnet, you should send traffic to 240.100. That is the firewall trust interface IP, and this route is going to override the default system route, because as I explained, in default system route, it asks if the web server subnet wants to communicate to 192.168.240.32/27, you should communicate directly to the database subnet. So using this route, we have overridden the system route. So let me go to the web server, and let me ping the database server. Let me get the IP address 240.36. Here also several things to explain. Ping 192.168.240.36. Okay. So you can see now we can ping. And I have to show you two things, interesting things. So let me go to the firewall. Firewall is locked out, so let me log back again. Let me enter my username and the password. So let me check my ping. Ping is stopped. The connection has been it's been disconnected. So let me get the connection again. I think this is the one. I think yeah, I cannot connect because I think because I had I think you just check the previous demonstration. Actually, I had a what do you call specific UDR in order to access our the web server directly without going through the firewall. So let me go to the subnet and check. Let me go to the route table and check the UDR trust route. So that is the route table assigned to the web server. Subnet, this is my PC. It says 192.135.212.46. So let me check. Let me refresh. Yeah, it has been changed. So my IP has been changed, public IP. So then I cannot edit this. I have to delete this entry and enter new entry. So let me add another entry. So that I cannot access web server directly. But directly accessing is not that much secure. So what I'm going to do is I'm going to install Globalprotect SSL VPN in Palo Alto and allow remote administration through the Palo Alto secure VPN. But I'm going to do that in next demonstration, because at this moment we do not have enough time to do all these things, because I would like to explain all the theories behind this inter-subnet east-west traffic routing. So let me go to the window and try to restart session. So I think it has been added, but it takes some time, as I already explained. So let's wait some time. So now I should be able to access the web server directly. So let me restart again. Okay, now it's fine. So let me log into the web server. Okay, so let me get this IP database IP. I cannot remember the IP. We have to restart it as well. So let me close and start again. DB, this is DB, open, enter the username and the password. Okay, so let me get the IP address. Sorry, IP, that is 240.36. So let me initiate another ping. 192.168.240.36. Okay, now we can ping. So let me go back to the firewall, and I want to show you something. Let me go to monitor tab, and the source address is 240.4. That's fine. And okay, so let me filter the let me filter the destination IP. So this is the destination IP. I'm going to show you interesting thing. So here you can see that we can see the ping is working. Okay, here this is our trust subnet, right? This is our trust subnet, and here to zone, this is some trust subnet, but our expected scenario was intra-zone from trust subnet to trust subnet. So let me explain it here, because these things are really important when it comes to troubleshooting. So that's why I'm explaining. Actually, our expected scenario was traffic coming from the web subnet to trust subnet or the trust interface or the trust zone, and going out from the same zone to the database subnet. So in the firewall log, what we expected was from zone trust and destination zone trust. So this was expected. But the problem is we can see something else. Let me go to the firewall. So we can see trust to untrust. Why is that? So let me explain the scenario. So let me go to networking and virtual router and default virtual router and static routes. Here in the virtual router, we do not have any specific route entry mentioning the database subnet. So our database subnet is 240.32. So in that scenario, as I already explained, in networking theories, longest prefix match. So here, then the more broader prefix is going to be matched. So that is the default route. That is the default route. Okay. So then what happens is here traffic comes to the firewall. So let me change the color and explain you. What is it? Let's say green. So traffic comes to the firewall. Traffic comes here. So then the firewall checks how to send that traffic back to the database subnet. It does not have the specific route. So but it has a more broader route, that is default route. So default route is towards the untrust interface or the untrust subnet. So firewall is sending the traffic out of the untrust interface. And then I think you can remember I told you that all the subnets in Azure, they can communicate each other by default. So the untrust subnet knows how to send that traffic back to database subnet. So then the untrust subnet send that traffic back to database subnet. Okay. So then what do you think? So what is the return traffic? So do you think the database subnet is going to send traffic back to the trust interface or the untrust interface? No. The database subnet would send that return traffic directly to the web subnet. This is the asymmetric routing scenario here. So let me confirm that by going to the firewall. Let me go to monitor tab. Let me go to bytes. So sorry, I'm really sorry because I have an issue. Okay, here actually I like that happened here. You can see byte sent. What is this byte sent? Byte sent is the bytes that has been sent from web server to the firewall. Okay, in order to access the database server. So then we have byte received. But my expected scenario was byte received 0. Byte received 0 because as I explained, the expected scenario was traffic going out of the comes to the trust interface and going out of untrust interface and come to the database and then directly returning to the web subnet. But here, so let me explain that. Let me go to here. Let's check the source net because we have put a generic source net here. This is this communication. So let me go to source net source. See, this net source IP is 192.168.240.132. So what is that IP? So let me go to the interfaces. See, this is the untrust interface IP. So that means what happened was, so let me change the color so that you can understand. Let me get red, not red, but some different color. Let's say this color or black color. So what happened was the web server sent traffic to the firewall trust interface, and because of the default route, that firewall send the traffic out of the untrust interface. While it is exiting from the untrust interface, due to the generic NAT rule we have placed. So let me show that because in previous demonstration I placed a NAT rule in policies NAT. Here we have web internet access. This NAT rule because it's asked if traffic comes from the trust interface to untrust interface, please NAT it to firewall untrust interface IP address. Okay. So here because of that, so this traffic, the traffic from the web server to the database server, when it exiting due to the default route, it is exiting from the untrust interface. It has been NATed to the firewall untrust interface. So then traffic comes to the database server, and the database server sees the source IP of the request or the ping request, that is firewall untrust interface IP. So then web server send the return or the echo reply back to the firewall untrust interface. So then the firewall checks its routing table. It has a route about this web server subnet. Now let me show that. In the firewall virtual router, it has a route because we put a route previous scenario. Here it has a route. So let me expand this. It has a route. If you want to reach 192.168.240.0/27, then send out the traffic from 1/2 interface and send it to 240.97. So that is mean 240.97 is this trust subnet. This trust subnet second IP, that is trust subnet default gateway IP. So then the firewall send that traffic back to return traffic back to this trust subnet. This trust subnet default route IP. Then this default router will send that traffic back to the web subnet. So that's what happened. Okay, so let me exclude that netting scenario from the firewall in order to explain you the asymmetric routing scenario. That is where traffic initiating from www subnet and sent to the trust subnet or the trust interface of the firewall, and due to the default route, and it is going to be sent out of the untrust interface of the firewall. And if we are going to remove this NAT, so then the traffic is not going to be source netted. So then traffic would be sent back to the database subnet, since this untrust subnet of the firewall knows how to send traffic back to the database subnet, because in Azure all the subnets are having routing by default. They have routing. So this untrust subnet send the traffic back to the database subnet, and then the database subnet would send then return traffic back to the web subnet directly. So then the asymmetric routing scenario should happen. So let me remove that source NAT. Let me just disable this web internet access, that is the source NAT. Let me disable that NAT. Okay, and commit. So then our expected outcome is, in the firewall logs we should not be able to see any return traffic. So that means received bytes. We can see the ping is working. The ping should work. So let me wait this to complete. Okay, it's completed. So let me go to the this window. Now you can see the ping is fine. Ping is working. This ping is from the web server to the database server. So let me go to the firewall traffic log and let me refresh. And let me go to the, see here, now we cannot see any NAT IPs. We do not have any NAT IPs. Okay. Let me go to the bytes. You can see now. Here in previous, when the NAT was applied, we can see we have bytes sent. So that means the traffic from the web server to the firewall, and the firewall send that traffic back to the database server. So that is bytes sent. But here you can see the previous scenario, because of the source NAT, the database server sent that return traffic back to the firewall untrust interface. And then the firewall sent that traffic back to the web server subnet. But since we have disabled the NAT rule, here you can see the byte received is 0, because this is asymmetric scenario. Even though the traffic from the web server to the database server going through the firewall, but now the return traffic is not coming back to the firewall. But the ping is working. Here, ping is working. Because this return traffic, this asymmetric scenario happens, www server send traffic to the trust interface of the firewall, and the firewall, because of the default route, it sends the traffic out of the untrust interface and come to the untrust subnet. And the untrust subnet by default knows how to send traffic to the database subnet, since by default Azure subnets can communicate to each other. So it sends that traffic to the database server. So then the database server sends that traffic back to the web server directly, because it knows how to send traffic back to the web server. So that is asymmetric scenario. But our actual expected scenario is we have to send traffic to the trust interface of the firewall, and then the trust interface of the firewall send the traffic back to the database server directly without going through the untrust interface. So then in order to do that, we have to put specific route in the firewall asking that if you want to reach 192.168.240.32/27 subnet, just send that traffic back to the trust subnet default router. So that is the second IP of that trust subnet. So that is 192.168.240.97. So let me correct that first. So once we corrected that, our expected scenario in the log is this untrust, two-zone untrust. Currently it's untrust. This should be changed to trust. So let me go to network and virtual router. Let me open the virtual router. Okay, so now I'm in the virtual router. So let me go to static routes, and we are going to put a specific route for the database subnet. So let's say DB route. So database subnet is 192.168.240.32/27. Okay. So then this should be sent out of 1/2, that is the trust sub interface, and the IP should be the trust subnet for second IP 192.168.240.97. Okay. So then let me click OK. Now the default route is not even going to be used, since the in routing theories it says longest prefix matched. So then when the web subnet is trying to communicate to database subnet, this longest prefix, so that is our new route entry is going to be matched. Now we have added that route. So let me go back to the web server. Now even still the web server is having the ping. So let me go to the monitor tab and check whether we can see our expected outcome. So this untrust should be changed to trust. So still we cannot see that. Okay, I know why we cannot see, because you just note here the time is 4:27, so 16:27:26. So I'm just reloading. It is not 27, 16:27:38. Just note this. See, no, it's getting changed. So that means still it is sending to the untrust zone. So let me check the. I'm really sorry. Even though I changed this, I did not commit. I have to commit it. Sorry. Let me commit it. Actually, once the commit is done, I'll show you why I asked you to just check the time. I'll show that, because I had a clue, because this is the issue now. But even though I'm committing this, I think most probably you won't be able to see the traffic. So I have that idea. So let me show that to you. So okay. So now let's see. Let me refresh few times. Okay, now let me check the time now, because I just want to show you that this log is not getting updated, because I have a clue in my mind, in my head. So it is getting loaded yet. So we have to wait. So let me refresh the window. So Can you just check my previous demonstration? I'm mentioning that it is important to not to do everything planned, because when we are teaching or when we are learning, don't do pre-planned. If I have done this pre-planned, so I would not be able to show you these scenarios, the asymmetric scenario and this netting scenario and all. So in that scenario, don't do that. Here, this now it's trust to trust, but let me go to the policies, because I can. I just want to check my logging, because in InterZone default. So let me check whether I have already enabled. I have already enabled log at session name. So in order to get the logs visible in the log window, you have to enable this, because by default this is not enabled. I think in previous demonstration I enabled it, so now it's fine. So now you can see our expected scenario: the traffic from the trust zone and send it to the trust zone. So let me go to the window and check whether we can see ping. Yeah, ping is working. So but here, even though here the traffic, the new traffic scenario, the traffic. So let me change the color. Or shall I draw this again, because otherwise you can't see. You can check. It's a mess now. So let me change the color. So go back here. So let me draw it quickly. So this is the firewall PA. This is untrust, and this is trust. Writing quickly, otherwise your time is going to be wasted. So this is www subnet, and this is db subnet. Okay. So let me change the color. Let me get the, what would be the white repeating? No, it's okay. Here. Okay, this now the current scenario is traffic is sending to the trust interface of the firewall, and because of the route UDR entry in the www subnet. So then, because of the previous routing entry in the default route of the Palo Alto firewall, that is going to be sent back to the database within the same zone. But the thing is, the return traffic should return to the web subnet directly without going back to the Palo Alto firewall. So let me confirm that. Let me go to the firewall logs and let me show you. Here you can see the byte received 0. So byte received means so byte sent is this. Byte sent is this. So traffic from web server to the database server. Byte received is this. Database server returning traffic back to the web server. So that is byte received. So let me give you the reason. So when it comes to network virtual router in the Palo Alto firewall, here and static routes, here we do not have sorry, actually nothing to do with the Palo Alto firewall. Actually I have to go to the Azure virtual networks, and virtual networks, virtual network is F-like VNet, and then we have to go to subnets, and we have to go to our database subnet, F-like TP subnet. Okay, here you can see we do not have any route table. So here we have to have a route table in order to instruct the any traffic reaching this web server subnet should be sent back to the firewall trust interface. So that should be done. So let me create a route table. Route tables, let's say db route, create one. Okay, here resource group F-live, and region should be West US. I'm really sorry. West US, and a name is let's say db route. Okay, so then let me create that. Okay, it's running the final validation. It's done. So let me press create. I think you can understand, because I think our one node got closed. So let me, okay, here in database subnet we do not have a, what you call, sorry, we do not have a route table. So in that scenario, it is not sending route traffic back to the trust interface, return traffic. So let me go to the route tables and put a route entry. Let me refresh. This is DB route. So let me open that and go to routes and let me add the route. So this is www route, because we are going to have prefix, that is web server subnet traffic prefix 240.0/27. So let me select virtual appliance and enter the firewall trust interface IP 240.100. Okay, so invalid IP. So why is that? Sorry, here. That's fine. Okay, let me click OK. So now we put a route entry. When this database subnet, when this database subnet wants to communicate to the web subnet, please do not send it directly. Just send that back to the firewall trust interface. So that is, I am overriding system routes and putting a user-defined route. So that is that. So let me go back to the Azure window. Now it has been added. So now let me check the ping. It is working. So let me go back to the firewall and confirm whether we are getting the response traffic back to the firewall. So here the if byte received is non-zero, so not zero, so then our route has been added. So let me go here. So here still it's still 0. So let's wait some time, because I have already explained you that it takes some time. No, I actually I could not be able to do something. So here, even though I have created the DB route, I have to assign that to the virtual subnet, or the subnet in the virtual network. So let me go to subnets. Let me go to F like DB and route table and DB route. You have to assign it here. Save. So it is being saved. So it says it has been saved. Let me go back to the firewall and let me refresh. So if the byte received is zero, not zero, so then our route has been added. So it takes some time. So let's refresh again. Not yet. So refresh. So it takes some time. Not yet. Refresh. Not yet. Let me refresh again. Still we haven't received. Let me check the ping. Ping is fine. And let me check the route table, because it has been added to this database subnet DB route. Let me check the route. It says 192.168.240.0. So let me check the web subnet IP address range. 192.168.240.0.27. So that's fine. No issue. So that's fine. So let me refresh again. Okay, now you can see. Now you can see the byte received. See, so that means now our scenario is fine. The traffic initiated from the web server, and that is trust zone, and sent through the trust zone, that is intra-zone traffic, and sent to the database server, and the database server send return traffic back to the firewall because of our UDR. So now it's totally fine. So here, now it's totally fine. Let me go to one note. Now our final destination, or the final scenario is fine. So let me explain one more time. Let me get the green color. Okay, this is a scenario. In a web server, we initiate a ping, and So in UDR, we ask that traffic destined to the database subnet. In UDR, we ask it to send to the firewall trust interface. In firewall trust interface, we put a route that if the traffic is destined to database server, please send that to the trust subnet second IP, that is the default route IP of trust subnet. So it send that to the route IP, so that it will forward that to the database. Okay, so that is intra-zone traffic, because traffic comes to trust zone and our traffic will be sent back from the trust zone. Okay, so then the database server, we have a UDR. If you want to reach the web server subnet, you have to send the traffic back to the firewall again trust interface. Here it will send the return traffic back to the trust interface of the firewall. In the firewall, we put a route entry. If you want to reach the web server subnet, just send that traffic back to the trust subnet second IP, that is the default route IP of the trust subnet. So it will send that return traffic back to that subnet virtual route IP, or not the default route IP. So it will send that traffic back to the web server subnet. So this is the scenario, and we have intra-zone traffic enabled. So but here we have to put, because we are allowing traffic because of default intra-zone rule in the firewall. Default intra-zone rule. Intra-rule. So what we are going to do is we are going to disable that, or deny the rule, and then we are going to put specific rule. So let me go to the the ping window. It's working. So let me go to the firewall policies, and I'm going to, you have to do this because otherwise all the traffic is going to be allowed. So I'm going to the rule, I'm going to deny that. So once I deny that, my ping is going to be stopped. Okay, let me wait for the commit operation. So let me get the window and check whether the ping is going to be stopped. Now you can see the ping has stopped. So let me go to the firewall and confirm. In monitor tab, let's check. So here, let me refresh. Here, see, policy denied. Now what we have to do is, in Azure deployments, we have to block all these two rules, and we have to put specific rules. I'm going to put a rule called intra-zone rule. That is the rule type we need to put here. Allow web to DB ping. Okay, this is the name, and rule type, this should be changed to intra-zone. Once you change that, you will be able to say something. Here you can select source zone. This is trust. Source address, here I'm not going to put the address, I'm going to put a generic rule. In the destination tab, you don't have to put the zone, because since it's intra-zone, the firewall knows this is between same zone. But if you are going to, let's say you are going to have universal rule, the destination is enabled. But if you are going to use a intra-zone rule, even though you can put the source zone, you cannot put destination zone. Obviously that should be the same zone. Here in application, I'm going to allow just ping. Or otherwise I can put we are not going to use any application. That application is any. So I just want to put a generic rule, and action is allowed. So let me click OK. So this is our intra-zone rule. Here you see that we cannot ping. So let me commit. Now our ping should get started now. So let's wait for the commit operation. Now I think you got the idea that how this east-west traffic routing scenarios, and how to enable it, and how to route traffic through the firewall, and how to put routing entries in order to facilitate all the subnets and all. Now it's working. So now my demonstration is completed. So I think you have obtained some idea about this east-west traffic steering through the Palo Alto firewall, and intra-zone traffic, and how the Azure level routing works, and the comprehensive idea about how the how the asymmetric traffic scenarios can be occurred, how to solve those traffic scenarios using routing, and how net can net can change the behavior of traffic, because the previous source net was a mistake actually, because in previous demonstration I put that net. In this demonstration I go my traffic got netted, then we had some other traffic scenario, so then we troubleshooted and we sorted that. I think that should be the way we have to learn things, and we have to teach things, and that is the best way. But in production environment, you don't have to do those things. You have to do specific things to make it enable or to make it work. But when you are learning and teaching, you have to have this kind of a different scenarios and try to troubleshoot on the go, or lively try to do the troubleshooting. Okay, thank you so much for your time. So I'll meet you in the next demonstration. Thank you so much.